Now we'll take up in the next section, which is on the mathematical way to divide a line segment according to a given ratio. Now there are two ways to do this, okay? The book brings you straight away to the formula on page 18 of your tables. So if you go to page 18 of your tables, at the very, very bottom of that page, there's a formula that allows me to divide a line segment by a given ratio. And the formula will come up on the screen in a few moments, involves both points, x1, y1, x2, y2, which are the endpoints of the line segment, and it also involves a and b, which are the numbers of the ratio that's given in the question. Okay, now this will all become very apparent when we start to do a couple of examples and show you how to fill this thing in. The second way to do it is by inspection. And if I was asked which way I would prefer to do it, it would be by inspection, because the formula is mechanical and it's easy to make a mistake when you're filling things into the formula. But when you're inspecting a point of division on a line segment, it's actually far easier to do once you understand what the mathematical definition of a ratio is. Okay, a ratio is a whole number division of an object into two or more parts. All right, so 3 is to 1, 4 is to 2, 7 is to 6, etc. But you'll never have 3.5 to 7.5. You don't ever have halves. So ratios are quite easy to deal with because they deal with whole numbers. All right. So let's move on into the slides and see what they say. If we're asked to divide a line segment according to a given ratio, then we simply use the formula on page 18 of the tables. What does the formula look like? There it is there. Or, which by the way is the point of division on the line, is equal to bx1 plus ax2 over b plus a, comma, by1 plus ay2 over b plus a. Now what that does, if you notice, is it gives or the x and the y coordinates. So in other words, it actually labels the point of division on your line. Okay, keep in mind x1, y1 is the first point on the line segment, x2, y2 is the other point on the line segment at the other end, and a and b are the numbers that are in the ratio. So you've got x1, y1, x2, y2, and then the ratio ab as the numbers into which you've got to divide this particular line segment. So that's what we have there, x1, y1, x2, y2, they're the 2 points on the line segment, and a and b are the values of the ratio. The second way to do it is by inspection. So what I'm going to do here now is I'm going to do a question, and I'm going to use both ways. I'm going to use the formula first of all, and then I'm going to show you by inspection. And you can make up your mind which one you want to use. You're free to use the formula if you wish to. It's always going to be in the tables, which is always in front of you. Or you can practice the inspection and get to understand fully what dividing a line segment in a given ratio is about. So let's take an example. A, minus 5, 3, and B, 3 minus 1, are 2 points. Find the coordinates of C, which divides the line segment. Do you notice the brackets? The line segment. So in other words, we're working in between A and B. We're not going beyond them. They're square brackets. In the ratio of 3 is to 1. So method 1 is by the formula. So I go to the formula and I write down what the formula says. That the point representing the point of division on the line is found by multiplying B by x1 plus a by x2 over b plus a, comma, then we have b y1 plus a y2 over b plus a. So really all you have to do is to make sure you label your points properly. So this point here is x1 y1, this point is x2 y2, and the ratio 3 is to 1 is a and b, and you carefully fill those points into the formula. So b times x1 is 1 times minus 5. 1 times minus 5. So that's b times x1. Then plus a, which is 3, times x2, which is 3, all over b plus a, which is 3 plus 1, which is 4. So there's the first point. Next one, b, which is 1, multiplied by y1, which is 3, plus a, which is 3, multiplied by y2, which is minus 1, all over b plus a, which is 4. And then when you carefully do the addition and the multiplication, 5 times minus 1 is minus 5. Then you have plus 9, which gives you 4 over 4, which will be 1. We worry about that in a moment. Then 3 plus minus 3 is 0 over 4, giving you the point 1, 0. Now what do? Go back to my line segment, find the point 1, 0, and that point there divides my line into the ratio of 1:3. So there's the 3, and there is the 1. So there's your line divided into 1:3. Okay, now that's one way to do it. There is, of course, the second way to do it, which is by inspection. And here's the way in which I would ask you to do this. If the ratio is 1:3, that means 1 part to 3 parts. So altogether, there are 4 parts. Okay, so you're dividing your line into 4 parts, 3 of which will be before the point of division, 1 of which will be after. Just keep that in mind. Now, the next thing we do is we inspect the x's. Okay, x goes from -5 all the way down to 3, or up to 3, I should say. -5 up to 3. So these are the x values we're dealing with, which is what? That happens to be an increase of 8. All right. Now, what about the y's? Let's inspect the y's. What happens? Y goes from 3 down to -1, which is a decrease of 4. Now, the increase or the decrease in the x and y has to then be divided by the total number of parts. So, +8 gets divided by 4, which gives you 2, and -4 gets divided by 4, which gives you -1. And the last thing we do then is we take those numbers and multiply them by each part of the ratio. 3 times 2 is 6, okay? Which means now I go from -5 up 6 units to the point of division. -5 plus 6 brings me up to 1. All right, so the first part of my point is going to be 1. Then I want to go -1, and I want to multiply that by 3, because again I want to find out where the first 3 units are, which gives me -3. So starting at 3, I want to go down by 3, which brings me to 0. It's exactly the same point as before, a little bit less work, okay, but again by inspection. So listen to it again. The ratio is 3:1. That means that you're going to be dividing the difference in the x's and the differences in the y's by 4. So x's go from -5 to 3, which is an increase of 8. If you divide that by 4, you get each piece being 2. Now, if the ratio is 3:1, 3 of those pieces will be 6 units. So you go to -5 and travel up 6 units to 1, and that's the first answer. For the y's, you're going from 3 down to -1, which is a decrease of 4. That decrease of 4 has to be broken into 4 parts. So therefore each part will be a decrease of 1. 3 of those parts are before the point of division. So therefore 3 times -1 is -3. So you go to the y coordinate, which is 3. You take 3 from that, it brings you to 0, and that's your point. Now, totally up to you what you want to do. If you want to use the formula that's in the tables, do so. If you want to do it by inspection, you can do it by inspection. Okay, so let's do a couple of worked examples as are given in the book. This is on page 273, question 2. Q, which is -26, and R, which is 1227, are 2 points. Find the coordinates of P when P is a point on QR, the line segment QR, such that the line segment QP to PR is 3:4. Now, 2 things we've got to look at here. I'm going to do this by inspection. Okay, I'm not going to use the formula. You can use the formula if you want to. If you wanted to use the formula, that'd be x1, y1, x2, y2, and 3 and 4 would be a and b. Fill it into the formula, get your answer. But just watch how we do this by inspection. Let's inspect the x's. Okay, x goes from -2 in the first point up to 12. Now, what's that? That's an increase of 10. Okay, so we'll come back to that in a moment. Let's inspect the y's. What happens? Y goes from 6 all the way up as far as 27. So that's an increase of 21 units. So from 6 up to 27, which is an increase of 21 units. Okay, so plus 21. So we go from -2 to 12. Sorry, it's plus 14, isn't it? -2 to 12 is plus 14. So the x's go from -2 to 12, which is plus 14. The y's go from 6 to 27, which is 21 units. Now, what's my ratio? My ratio is 3/4. Meaning what? Meaning that there are 7 parts in this division. Okay, so therefore you take both of the differences and divide them by 7, which gives plus 2 here for the x's and plus 3 for the y's. So therefore every division on the x's is going to be 2 units. So look at 3 is to 4. Let's take care of the 3. 3 of those units would give me an increase of 6. So therefore, if I start at -2 and I go up 6 units, I end up at 4. Okay? And now let's do the same with the y. The y is broken into 7 parts. Each one of those parts is 3 units. And 3 of them happen before the point of division. 3 3s are 9. So you go to 6, you add on 9, and you get to 15. And that happens to be the point of division. That's P that they asked for. Yeah, find the coordinates of P. That's it. Now let's just check by the formula to make sure that works. So what have we got? We've got x1, y1, we've got x2, y2, and we've got A and we've got B. So let's just make sure that the formula gives me exactly the same answer. The formula says B times x1. So that's 4 times x1, which is -2, plus A x2, which is 3 times x2, which is 12. And that's all over 3 plus 4, which is 7, comma, B y1. So B is 4 times y1, which is 6, plus A y2, which is 3 times y2, which is 27. Okay, and that's all over 7. So when we do that on the calculator, what do we get? 4 times -2 is -8. 3 12s are 36. So 36 minus 8 is 28. Divided by 7, so far so good, is 4. Take the next one. 4 6s are 24. And 3 27s. So 3 times 27. And that's equal to 105 divided by 7, which gives you 15. Snap. So it's totally up to you, whichever way you want to do it. You can inspect the x's, see what their increase or decrease is, divide that increase or decrease up into the total number of parts that's given by the ratio, and then when you've broken it down to one part, apply those parts according to the ratio that's given, or you can simply use the formula. Totally up to yourself. Okay, next one. X, which is -2 minus 1, y, which is 2, 1, and z, which is 4, 2, are 3 points. Prove that x, y, z are collinear. Now, that collinear, every time you see the word co, it means together. Okay? Cooperation means working together. Operate is work, co is together. So cooperation is working together. So therefore, collinear is together on the same line. Okay? No harm to make a note of that. It's together on the same line. Now, there's 2 ways to do this. Okay? First of all, if x, y, and z are collinear, they're going to form a triangle with no area. Just think about that for a moment. If x, y, and z are on the same line, you get, for all intents and purposes, a flat triangle with no area. So what you could do is you could fill those into the area formula, as I showed you previously, turning one of them to 0, 0, and then bringing the other 2 according to the same translation. Stick them into the absolute value of x1, y2 minus x2, y1, and see what answer you get there. You should get 0. And if there's 0, if these 3 don't form a triangle, then they must be on the same line. But there's an easier way. If they're on the same line, then the slope between x and y should be exactly the same as the slope between x and z. All right, think about it. If you have a line like that, and let's say there's x, and let's say there's y, and let's say there's z. Okay, so x, y, and z. They're collinear. Now, I want to prove that they're collinear. Doesn't it make perfect sense that the slope between those 2 would be exactly the same as the slope between those 2? So all what I would do here is I would take x and y and work out the slope. Now, it's given in terms of 2 points. So therefore, we use y2 minus y1 over x2 minus x1. Keep that in mind, between x and y. So let's see what that works out as. y2 minus minus 1. So 1 minus minus 1 is 2 over x2, which is 2, minus minus 2, which is 2 plus 2, which is 4. So we end up getting a half. So the slope between x and y is a half. If the slope between x and z is a half, then z has to be on the same line as x and y. because it's the only way that they can have the same slope as xy. So let's see what happens. So we've got x and y this time. So y2 again, y2 minus y1 over x2 minus x1. But this time you're using z and x. So y2 minus y1. That becomes 2 minus minus 1, which is 2 plus 1, which is 3. Over x2, which is 4, minus minus 2, which is 4 plus 2, which is 6. Hey presto, xy has exactly the same slope as xz, so therefore x, y and z are collinear. They are together on the same line. Okay, and then it says now, find the ratio by which y divides xz internally. So in other words, they want me to take the line x, y and z. Now that I've proved that they are collinear, this is minus 2 minus 1. This point here is 2, 1. And this point here is 4, 2. And they're asking me to work out what the ratio is between these. Okay. Now, the ratio would be exactly the same as the relationship between the difference in the x's here and the differences in the x's there. So you just pick x or y to deal with. So let's see. Minus 2, this x value, becomes 2. That's an increase of 4 units between those two x's. Here, 2 goes up to 4. That's only an increase of 2. There's your ratio. Your ratio is 4:2. However, we don't call it 4:2 because a ratio is the simplest whole number relationship. You have to simplify 4:2 down to 2:1. And that is the ratio that exists between those two parts of that line. See how easy it is by inspection? I think inspection works because it means you've got a deeper understanding of what the internal division of a line segment is all about. Now the same thing would happen with the y. Just to check. Let's just check and see, do the y's give me the same ratio? Minus 1 becomes 1. So that's an increase of 2. Okay, so we've got an increase of 2 here between those y's. And here we've got 1 becoming 2, which is an increase of 1. So we get exactly the same ratio for the y as we do for the x. So if you're looking for the ratio, compare the x's before the point of division to the x's after the point of division, and that is where the ratio will come from. And you can do, as I said already, you could do exactly the same with the y's if needs be. Okay, so our third and final example. A is xy, B is 0, 1, and C is minus 2, 2. And these are 3 points. B divides AC internally in the ratio of 5:1. So they want you to find the coordinates of A. Now look, a diagram always helps these things. A diagram will always help you. So what are we told? A, there, is xy. Okay. B is 0, 1. And C is minus 2, 2. Now don't worry about where the points are. This is just a rough diagram just to give you an idea as to how they are related. They're on the same line because we're told that B divides AC. So B is between AC. In the ratio of 5:1. Okay, so what that means is that B divides AC in a ratio of 5:1. So the ratio here is 5 and the ratio here is 1. Okay, so what I'm going to do now is I'm going to take a look and see, okay, 1:5. So the difference between the x's here would be 5 times greater than the difference between the x's here. So think about that. Let's look at the x's. The x's go from minus 2 to 0. So that's an increase of 2 going that way. This is going to be 5 times greater, so that's going to be an increase of 10. See? To keep the ratio the same. So if the x values increase by 2 going to the left between B and C, then they will increase by 5 times that, which is 10, going from B to A. So straight away, x is equal to 10. Now what about the y? Exactly the same thing. Y goes from 2 to 1. So that's an increase of 1. Sorry, decrease of 1. So y goes from 2 to 1. So that's a decrease of 1. The distance between the y's of B and A will be 5 times that decrease. So if that's a decrease of 1, this will be a decrease of 5, bringing y down to minus 4. So what's the point we're looking for? The point A is equal to the point 10 minus 4. Okay, inspection works. Now, you can see what happens if you start using a formula when you're dealing with this. The formula becomes a little bit more difficult because you have two unknowns in the one question, and the formula, you're going to get yourself tied up in all kinds of knots. I think it's much easier if you do it by inspection and work out what the ratios are between the 3 points. The one that's in between A and C in this case here, which is B, or whatever point internally divides a line segment between any two other points. So I'm going to leave you with these. I'm going to leave you at page 273, question 1, 3, 4, 6 and 7, and they all involve you taking a line segment, dividing it up into a given ratio, or give you a line segment and ask you to find the point of division or ask you to find the ratio. Try it by inspection. If you want to lean towards something, go by inspection. Don't really fall back in the formula. It makes algebra a little bit too complicated when we get to the ones we have to do in reverse. So try them by inspection, and in our live class, we'll see how you get on.